Okay. Oh, yeah, sorry. You have to tell me if I get it off. Is that off?
Yeah.
I, honest to God, can't hear it. Which is really scary. The older you get, the worse your ears get, I guess. So, really annoying, huh? Oh. Well, you guys have my sympathy dealing with a lot of material very quickly. So,
how much of the new material, like how long?
Okay, yeah, good question. So, how much of the material in the exam will be new material? How much of it will be old? I keep it proportional to coverage in the class. So it works out to be about 20 to 25%, maybe 30%. Oh, it's not 30%, maybe 25% is new material, and the remainder is old material. So I recommend using the exams I've given you as an outline, because I'm not going to go back and pick out obscure things I haven't talked about. But the topics that I've asked you about are definitely things that I will be thinking about as I'm writing the exam. When I write the final exam, I sit down with the exams that I've done and look at those and think about questions relative to that.
It's going to be the same format.
Same format. And the exam will be about 150 points. So it'll be longer than the exams that you've seen, but time shouldn't be a factor, really shouldn't be a factor. I can give you a few more minutes on the exam, but I definitely need to be done by no later than 5:30 tomorrow. So, but I could give you up until that time if necessary.
Will like section 1 be on section 2 and section 3, or is it evenly?
Yeah, I haven't changed them much on the first and second exams. If I change it on the final, it probably would have a little bit more short answer than it would problem solving, but it wouldn't be significantly different. They usually don't change that much on the final. One of the reasons I make short answers a little bit more on the final sometimes is because there's usually a scramble to get grades in. And grades are due by Monday, so I don't anticipate much of a problem with that, but there might be a few more short answers proportionally.
For the finals, does that mean that we won't be able to, if we want to, speak anything for the grading?
Yeah, so if you have a question about grading, then as always, you're always welcome to come and talk to me.
Okay.
Yeah, yeah.
So will they be available on Friday?
I don't know if they'll be available on Friday, but they will certainly be available by Monday. Yeah, yeah. And if we make an error or something, and on your exam, then we can change grade. That's fairly straightforward to do. It doesn't happen very often, but it does sometimes. Yes, ma'am.
So when you were saying you look at the older exams, the ones that we've currently taken?
Oh yes,
or
the
you
ones
did?
you've taken. So don't go study other exams.
Okay.
That's not a good idea. So just some general thoughts. I guess I'll give you maybe some advice on this. So you've got a lot of material to get in your heads in about 24 hours, and I'm guessing you've probably been anticipating this some, so you've already done a lot of that studying so far. Especially in the summer, I think what people do is they take the newest material and they probably disproportionately put that on their cards because you don't have as much time to sort of absorb that in your heads, and I think that's not an unreasonable thing to do, although whatever works for you is what I think is the best. I think most people make their cards fairly late, which is good because that gives you as much time to get in your heads as much as you can, and then the things that you're just not really sure about, you can put on cards and get those together. I'll remind you the cards all need to be completely handwritten. You cannot paste something on there. You can't put a figure from somewhere else. They all have to be handwritten, and the cards have to be turned in with the exam. And my reason for doing that is not to be mean, but I keep the cards because I don't want you giving it to your friends because I think there's a benefit in making the cards. And if you give it to your friend for next year, your friend won't have the benefit of making the card. And as a consequence, it'll be of limited use to them. So to discourage you from giving the cards to your friends, that's why I actually keep the cards. So if you're really proud of your card, take a picture of it. Take a photocopy of it, okay? But I will keep the original card. Okay? Yes, sir.
Do you want our name written?
Yes, I'll want your name on the card, yeah. But you can put that on afterward, just big letters or whatever, so. And let's see. I think, like I said, summer class, you've got an awful lot of things to get together fairly quickly. That's one of the reasons that averages on the summer tend to be lower. But the grade distributions aren't significantly different. I would say I give the same proportion of A's, B's, C's, D's, and F's in summer as I do in fall or any other time that I teach it. The same happens on the e-campus class. Roughly the same proportions of A's, B's, C's, D's, F's. I don't set out that way to do it. When I look at my distribution of grades, I look to see how the grades are sorted, and if the grades, the way that they sort, actually ends up being what determines my final. But grades, surprisingly enough, usually end up in sort of a Gaussian distribution. Your class has been a little odd, I will say that, in terms of the distribution of grades. I haven't seen as much clustering, which makes it a little harder to decide where to make the cuts. But on the final, I'm guessing that by then you'll go back into a Gaussian, which is almost always what happens, but we'll see. Otherwise, I'll just give everybody Fs. So, yes, sir.
The first exam had a question that threw me for a loop.
Okay.
It was named everything that binds the hemoglobin.
Okay.
Which was scattered throughout 2 weeks of material.
Uh-huh.
Second exam had a question that said name 4 of the 7 things that covalently induce women,
Uh-huh.
which was out of the clear blue sky.
Yeah.
Which was spread out over another week.
Yep.
What kind of heads up for a question like that can we expect to see on the final that's going to
Well,
affect our grade drastically?
first of all, the hemoglobin didn't take 2 weeks, so it might have been 2 lectures, but I don't think it would be 2 weeks. Okay. But the other one was a bit more spread out. And I asked that question on purpose because I want you thinking broadly about what I've been talking about. This is partly a class of acquiring the language and the knowledge, but it's also acquiring a perspective of biochemistry. And so that question I put in specifically because I wanted to have you thinking about, wow, where have we talked about things being attached to proteins? And that partly requires you to sort of sort through it in your own head. In other words, if I went out and I said, okay, folks, here's 7 things that attach to proteins, I have no doubt that people would memorize that list of 7 things that I said attach to proteins. The exams are not aimed at getting you to regurgitate a list, but rather to get you to take and think, again, broadly about the kinds of things that we've done. And so I will generally have at least one question on my exams that will have students thinking broadly about problems. That may not be a list that I gave you, but they will be things that you should have in your head about things that we've talked about.
It's kind of hard because I think you said you test mainly, or you write the test mainly on the main concepts.
Right.
When stuff's spread out like that, then it's not the main concepts.
Well, they are main concepts. Absolutely. Every one of those that were the answers to those problems were things that we did talk about. I mean, we talked about Paula. We talked about phosphorylation of proteins.
In our minds if they are on the list.
Well, I can't see, I can't tell what you highlight in your mind, but what I'm thinking you should be doing is noting these things as important concepts. I'm not asking you trivial things there.
This is maybe redundant for you guys, but maybe if you could just like walk through the 7 things and explain to us how we would recognize that was there, in the discussion, just so that we could say, okay, when I'm looking at this, I need to categorize and understand that this is an important component.
Linking was what categorized them all together as being on the same level.
Right.
I'm sorry, I didn't understand.
The covalent linking is what did that. I mean,
Covalent linking is what made the 7 of them similar to each other and why them all together on the list.
Yeah, and I guess I was hoping that there would be some other way that we kind of tie them together.
but that's what the question asked. The question asked was, what was the covalent linking, right? I mean, I didn't ask it to be a trick question, and I honestly don't. I don't believe in tricking anybody in an exam question. That is not my aim in anything that I do, and I honestly don't think there's anything tricky in that question. I think that question says, what do you know about enzymes and how they get affected by these molecules? I talked about DIPF. DIPF is there to see if we have, in fact, a hydroxyl of a serine in an active site. I mean, I spent a fair amount of time talking about that. There was none of those things that I didn't spend time talking about. So I really don't see that those were anything tricky. It certainly was not my intention to trick you.
I guess it was they were taught all spread out, and then this.
They were.
Combined everything together, and made that deal that we bring together.
But that's what I'm saying. I mean, part of what you should be doing as a student is you should be acquiring, as a part of your education, a broad view. And so I'm testing you on your broad view. You're going to go out and you're going to work, you know, as a doctor or as a research scientist or whatever, and nobody's going to come to you and say, you know, here's the 6 things that I want you to pull out from your biochemistry and know those. They will expect that you will know them from your biochemistry. And they will expect that you will have that broad perspective. So I have to measure your broad perspective if I'm reporting in your grade what kind of, you know, perspective you had of the class. Yeah,
Do you do plus and minus grades?
certainly. No questions on the material? Yes?
So the final is like any conventional?
Nope, nope. So I don't do that, and I don't think that's fair to students, because what if you did really great on the first 2 exams and somebody else didn't do well, and I'm saying, okay, well, those first 2 exams that you really worked your tail off on, you know, I'm going to throw those out for consideration of grades. That's not fair. So, no, I'm not going to do that. And the syllabus says at the very beginning how many points each exam was going to have. And so if I don't stick to what I said in the syllabus, then, again, I'm not being fair to everybody. One of the hardest things you have to do as a professor is sometimes say no to that. And I will tell you there's sometimes some situations that are very difficult to have to do that. But you do it to be fair to everybody. And there's times that being fair to everybody, certain people that you have to say no to, you really feel like you'd like to be able to do it and you can't, because that's the only way it is to be fair. Yeah? Which one? PKA problem? Yeah, sure. Okay. Let's see. Why don't I turn this off? I'll turn the camera down to here. And if you've got one you'd like me to work through, I'd be happy to do that. Okay, let's see. Okay. Did you have a problem?
I checked on that paper that your handout for practice on the first.
Okay.
The bottom one would be most.
This one down here? Okay. So, okay, so I'm going to write it down here. So, let's see. I probably have these horrible writing pens. That's not too bad. Okay, so I got 1 liter of a 1 molar acetate buffer. And at pH 4.5 is mixed with 600 mils of a 0.5 molar acetate buffer at pH 4.8, okay? And then 1 liter of HCl, and that is just getting bad, isn't it? One liter of HCl, 0.1 molar, is added, okay? And so what is the final pH? Okay? All right, So this problem is really a problem of understanding how much salt and acid I've got in the first solution, how much salt and acid I've got in the second solution. Then HCl converts salt into acid. And then I know the final salt and acid, I'll be able to get the final pH. That's the broad scheme of what's there. That make sense?
Does it say 4.8 on the different pages?
What's that?
Are the pages 4.8?
This is 4.8, this is 4.5. Let me turn the lights on so actually, yeah. Okay, does that help? All right, so 4.8, 4.5, all right. Now, all right, so how do I do this? Well, pKa of the acetic acid buffer system is 4.76, all right? And so I've got to know, I'm going to think of, I need to know how much salt I have in the first solution, how much acid I have in the first solution, how much salt I have in the second solution, how much acid I have in the second solution, right? How many moles of buffer do I have in the first solution? Well, S1 plus A1 equals 1, right? 1 liter times 1 mole per liter, I got 1 mole of buffer. How many moles of buffer do I have in the second solution? Well, S2 plus A2 equals 0.6 times 0.5 is equal to 0.3. These are now moles. Right? Okay, I'll go back to my Henderson-Hasselbalch equation. I say the first solution has a pH of 4.5. Not plus, duh. 4.5 equals the pH, which is equals pKa, which is 4.76, plus the log of S salt over acid, S1 over A1. But I know that S1, okay, and A1 are related like this, so I could say A1 is equal to 1 minus S1, right? Okay, so I solve for S1. Minus 0.26 equals log of S1 over 1 minus S1. 10 to the minus 0.26 equals S1 over 1 minus S1. I simply solve for S1. S1 is some number I punch in a calculator is equal to, in this case, let's call it Z. That's just a number. A1 equals 1 minus Z. So now I know I've got Z and 1 minus Z. But these two. I'm similarly going to go through do the same thing for the other one, plugging in the appropriate pHs. I'll get another number. Let's call this X, and we'll call this 0.3 minus X. What's the total amount of salt and acid I got when I mix these two guys up? Well, the total amount I have is, I can say, well, my pH, my final pH, is equal to my 4.76 plus the log of S1, which was Z, boy, this thing is getting bad, plus S2, which is X, all over 1 minus Z, plus 1 minus X. And then I add HCl. What does HCl do? HCl converts salt into acid, so I'm going to lose salt, and I'm going to gain acid. There's my answer. Okay, that makes sense?
So Kevin, if you added NaOH instead of HCl, you'd do the complete opposite, right? You'd add salt.
Add
lose
and
acid.
subtract. Right. Right? That makes sense? Okay, so it's important to see it in terms of the big picture, in terms of what's happening in the solution, right? So I know that I've got a number of moles of this, I've got a number of moles. I've got to work with moles. I can't add concentrations. So I've always got to convert things to moles. But once I've converted things to moles, it becomes a pretty straightforward problem to step through. and eventually I get to my answer here. But you see, I didn't use a calculator. But I would have had to have shown, I would have had to have gone through and solved, which I didn't do here. But you can solve for that. That gets you to a number z, and then you've basically got it. Puzzle looks. It's been a while since you've thought about pKa. Other questions? Yes. Are we done? Yeah.
Can you talk about pKa and how it turns off glycogen synthesis and turns on
Phosphorylase A. You're talking about, you said pKa. You're talking about protein kinase A. And okay, so I should have. If I can still log in or not, I think I can. Pull it up for you. It's easier to talk about the figure, but in general, protein kinase A. Whenever you hear epinephrine, I mean, the first thing that you should think is protein kinase A is getting activated. Bang. Epinephrine, glucagon, protein kinase A is activated. Protein kinase A is a kinase, and it is a kinase that puts phosphates onto proteins. So I've talked about several proteins that puts phosphates on, but if we look at that scheme that I showed you, protein kinase A, actually maybe I won't use the computer. I'll just put it up here. So protein kinase A, which I'm going to call pKa, which I don't like calling, but I'll call it pKa, catalyzes the conversion of phosphorylase kinase from the no phosphate state to phosphorylase kinase with a phosphate on it. Okay? This guy is inactive. This guy is active. All right? Well, what's active phosphorylase kinase going to do? It's going to convert glycogen phosphorylase B into glycogen phosphorylase A. This is the more active form of glycogen phosphorylase. Okay? So that's what protein kinase A is specifically doing here. You've seen protein kinase A is active in phosphorylating several proteins. You saw it phosphorylating here. You saw it phosphorylating glycogen synthase. Okay? You saw protein kinase A phosphorylating the inhibitor. You saw it phosphorylating that G that the phosphoprotein phosphatase was attached to. And you also saw protein kinase A phosphorylating protein kinase. All of those things got phosphorylated by protein kinase A. Yes, ma'am?
Did you say that the monoamine oxidase is what deactivates the pKa? Or
Monoamine, I haven't talked about monoamine
you
oxidase.
said whatever inhibited the caffeine was what inhibited
Phosphodiesterase. Phosphodiesterase, yeah. So phosphodiesterase will break down cyclic AMP. And that's necessary to turn off the breakdown of glycogen. If you don't turn that off, you keep breaking glycogen down, you keep producing glucose. So if you inhibit the breakdown of cyclic AMP, you get more glucose. And so the reason I say you get a buzz from caffeine is that it inhibits the phosphodiesterase, which means that the cyclic AMP doesn't get broken down, glycogen breakdown continues, and the bloodstream gets a dump of glucose. So that's giving you a buzz from your caffeine. Yes, sir.
In regards to that, do your muscle cells actually use up all that glucose?
Do your muscle cells use all that
Is
glucose?
it like how does it all get used up if you just dump it in your blood?
Yeah, they can. If they need it, they will. Keep in mind that muscles have glucose only by one mechanism ultimately, and that's from the liver. Their only source of glucose is from the liver, because the liver is modulating how much glucose is there. So muscles, if they store glucose as glycogen, it came through the liver. It had to have come through there. I exaggerating a little bit because diet, I guess you get a little bit that'll dump there. But liver, even with diet, is modulating how much is going out. So the liver is having some control in how much ultimately ends up in the muscles, even if it ends up there in glycogen, because the precursor glucose had to be there. Will they use it all? Yeah, they will. And I find the epinephrine, the adrenaline story is amazing in terms of what happens when you get that stimulation and just how much muscles really can do when they have to. But yeah. Well, I see Anesia is scanning through her notes back there, with the exception of that. I think maybe we're done. I don't know. I don't see anybody else with any other questions.
Highlights from today's lecture.
I'll post them as quickly as I can, yeah. In fact, what I'll do is, I'll do like I did last night. I posted things as soon as I got the highlights done, then as each video came on, I got it done. So I will do that tonight. I'm going straight home from here and should have things going. I anticipate the first videos will be up and ready by probably 8 o'clock, will be my guess. And I'll have the highlights. That'll be the first thing I'll work on. Okay? All right, folks, study hard. See you tomorrow.